All right, strap yourselves in, because today we're going deep on Facebook.
Facebook.
Yeah, specifically TAO, Facebook's distributed data store for the social graph.
Ah, fascinating stuff. A real glimpse behind the curtain of, well, everything Facebook, really.
Yeah, I mean, think about it. Every comment, every friend request.
It's all powered by this system, this TAO thing, all those connections between users, posts. It's mind-boggling.
Truly, and the scale is just, well,
Epic. Billions of users, petabytes of data. Imagine serving up a personalized experience to each one every single time they log in.
right. Like, how is that even possible? That's got to be a challenge, right?
It's not just a challenge, it's a revolution. They had to rethink everything about data. See, most systems, they push data out to users.
Like, email.
Exactly, email. But Facebook, they do the opposite. They pull data on demand.
Pulled. So every time I'm scrolling through my feed.
Facebook is building that view just for you, live from their servers. Instantaneous.
Whoa. Okay, so that's a lot of pressure on their system then, right? To be like, super fast.
Lightning fast and efficient. Incredibly so. They couldn't just use any old database.
And they didn't start with this TAO system, right?
No, not initially. They were using like a combo of MySQL and Memcache.
Pretty standard stuff back then, I guess. But sounds like it wasn't enough for Facebook.
Not in the long run, no. Especially as they grew. The limitations started, well, they started showing.
What kind of limitations?
Think about it, the social graph. It's all about connections, right? What they call edges in the paper. Memcache, it's a key value store, right? Not great with these edge lists.
Like trying to find a needle in a haystack.
More like a book in a library, a really, really big library, without a card catalog.
Okay, I kind of see. So, like, if I want to see my friends list?
Facebook has to fetch the whole list every time, even if just one friend changed their, I don't know, profile picture.
Wow. Yeah, inefficient much.
Super inefficient. But that wasn't even the only problem. There was the coordination issue.
Coordinate.
Yeah. You see, with Memcache, the logic for managing the cache was spread out all over the web servers. Imagine that.
Like, too many cooks in the kitchen?
More like each library section having its own checkout, totally separate, no central control.
Yeah. Recipe for disaster.
Chaos. No way to prevent conflicts to make sure updates were happening smoothly.
Okay, and then there's the whole making sure everyone sees the most up-to-date stuff, right? Especially after changes, posting, that kind of thing.
Oh, absolutely. Consistency, super crucial for a social network, obviously. But here's where Facebook made a bold move.
Bold.
They decided speed and availability were more important than absolute consistency.
Interesting.
Think of it this way. Would you rather wait forever for your feed to load perfectly or, see a comment a few seconds late?
Yeah, I guess in the world of instant gratification, a little lag isn't the end of the world.
Exactly. So a little inconsistency, a fair trade-off for a smoother, faster experience.
Makes sense. But how did they keep things from going completely off the rails then?
Well, that's where TAO steps in. It's a whole different approach, really. It's not treating data as, like, simple key-value pairs.
So not the library analogy anymore.
Not quite. TAO implements a graph abstraction directly.
Graph abstraction, huh? Sounds kind of heady.
It's complex, yeah, but also elegant. Imagine it like TAO has its own map of the social universe,
A map, okay. I can kind of picture that.
Every user, every post, every comment, even locations, they're all objects on this map. And the relationships, like friendships, comments, they're associations.
So TAO understands all those connections. That's how it can answer those complicated questions so fast.
Exactly. It doesn't have to sift through a mountain of data. It just follows the associations, like, navigating a map.
Oh, like that example in the paper, right, with Alice checking into the Golden Gate Bridge.
You got it. Alice, Bob, the bridge, the check-in. It all becomes objects in TAO's graph.
And then, boom, TAO can answer those questions like, who commented on Alice's check-in?
Or, how many people checked into the Golden Gate Bridge today? No sweat. It's so much more efficient for the social graph,
So we've gone from a messy library to a super smart map.
Yeah.
Love it. But how does it actually work? Under the hood, I mean.
Well, at its heart, TAO still uses good old MySQL. That's where the data lives permanently. But to handle it all, they split it up, logical shards.
Like multiple library buildings, right?
Exactly, each shard on a separate server. Now, to access and get that data quickly,
That's the tricky part, right?
that's where the caching layer comes in, 2 levels. Leaders and followers.
Leaders and followers, huh? Okay, explain.
The leaders, think of them as, like, head librarians, right? Direct access to the MySQL. They handle all the writes, the changes.
Okay, and the followers.
They're spread out closer to the users. They mostly handle reads, the requests for information.
Gotcha. So the followers keep copies of the most popular stuff in memory, right? Like a shortcut.
You got it. So they can respond super quick. But of course, the information's always changing.
All right, how do they stay up to date with everything?
They have this system of cache maintenance messages constantly flowing. Imagine librarians whispering updates to each other.
Okay, cute. So whenever there's a change, a new friend request or whatever,
The leader sends out an update message to all the followers, the relevant ones anyway.
so they're eventually consistent then, just not like real time.
Exactly. But what if a leader server crashes? That's got to be a problem.
Oh, yeah. What happens then? Everything grinds to a halt.
Nope. The followers, they can bypass the cache and go straight to the database.
Smart. So they can still answer those read requests.
Exactly. And for write requests, they just redirect them to another leader who takes over, like a seamless handover.
Wow. A self-healing library, kinda. But all this complexity, there's got to be a trade-off somewhere, right?
Oh, for sure. Like we said, consistency is the big one.
Right. Prioritizing speed and availability means sometimes things might be a little out of sync.
It's possible, yeah. But Facebook has all these mechanisms to minimize that, and for most users, it's probably not even noticeable.
Fair enough. So all in all, a pretty impressive system. The paper mentioned billions of reads per second, low failure rates.
Remarkable. And it all goes back to that choice. Prioritizing availability over consistency really makes you think.
Yeah, it does. What are the implications,
Yeah.
for users, for developers? This is where things get really interesting, I think.
You said it. And that, my friend, is a great place to pause for now. We'll dive deeper into those very questions in part 2.
Back again for more TAO talk. Man, that last part really got me thinking,
Yeah, it's a lot to unpack, that's for sure.
It really is. All the stuff about availability over consistency, that's a bold move, isn't it?
Oh, absolutely. It really goes against the grain of traditional database design.
Like, in the real world, what does that even mean,
Right.
What are the implications?
Well, let's break it down. Strong consistency, right? It means everyone sees the same data at the same time, always.
No matter what, yeah. Seems pretty important.
Oh, it is. For certain things, anyway. Like, think about banking.
Right, if my account balance is off by even a penny, that's a problem.
Exactly. In those situations, consistency is king, no question. But for, say, a social network.
Not quite as critical, I guess.
Yeah.
A delayed comment isn't going to cause a financial meltdown.
Not quite. In most social interactions, a little lag here and there, it's not a deal breaker.
Right. I mean, what's really important is that the site is up and running, right?
Exactly. Smooth, responsive, always available. That's what users care about. That's where TAO shines.
So it's like Facebook saying, hey, a little inconsistency is okay as long as everything keeps working smoothly.
Yeah, pretty much. But, it's not like they just throw consistency out the window completely.
Right, because I could see that getting frustrating, right? Like things appearing and disappearing, getting different views and all that.
Oh, for sure. It can be jarring. Imagine, you like a post and then, poof, the like's gone for a second. Not ideal.
Yeah, not great. But didn't you say they have those, what were they called, those messages?
Cache maintenance messages, they're constantly working to keep things in sync behind the scenes.
Right, the librarian whisper network.
Exactly. So it's eventually consistent,
Yeah.
even if it's not always instantaneous.
And for most users, I'm guessing those little blips, they probably don't even notice, right?
Most likely. It's all about finding the right balance. And for Facebook, that means a little inconsistency is okay if it keeps the platform fast and reliable.
Makes sense. So how do they actually achieve all this amazing performance, I mean? What's the secret sauce?
Well, there are a few tricks up their sleeve. One of the big ones is shard cloning. Remember how we talked about shards dividing the data?
Yeah, like the multiple library buildings, right?
Yeah. Now, imagine one book in one building suddenly gets super popular. Everyone wants it.
A bestseller.
Exactly. That's
Yeah.
what happens in TAO when you get a hotspot. A specific object, like, say, a celebrity's profile, gets slammed with requests.
Ah, makes sense. So what do? Just let that one server get crushed?
Nope. Instead of having just one follower handle that shard, they make copies. Lots of copies.
Copies of the data.
Yep. And they spread them across different servers, like the library, making extra copies of that bestseller.
Ah, smart. So no one server gets overloaded and things keep moving.
Exactly. Simple but effective. And they take it even further with something called client-side caching.
Client side, like on my computer.
Exactly. Your browser does it all the time, right?
Hey.
Stores images, website code, so it doesn't have to re-download everything every time.
Right, right. So TAO does the same thing for, like, super popular stuff.
Exactly. Those celebrity profiles, for example. Skip the server altogether, store it right on your device.
Wow, okay. So much faster.
Way faster, cuts down on all that data transfer. But of course, keeping those caches consistent, that's a whole other challenge.
I bet. How do they even manage that?
Each item in the cache gets a version number, right? When the
Yeah.
client asks for it, it sends that number along. If the data hasn't changed, the server just says, yep, you're good. No need to resend the whole thing. Efficient. Right?
Super efficient. Man, they thought of everything.
Hmm.
Oh, hey, what about those high-degree objects? The paper mentioned those. They sounded tricky.
They can be, yeah. High-degree objects, lots and lots of connections, like a celebrity with millions of followers, right?
Makes sense.
The thing is, TAO doesn't cache all those associations, just a portion of them.
Okay. So, like, if I want to see if someone way down on that list is a friend of mine.
TAO might have to go all the way to the database, even if the answer's no. Not ideal.
Yeah, I can see that being a problem. So how do they get around it?
Well, one way is this ASOC count function. It's like checking if a book is in the library before searching for it on the shelves.
Ah, I get it. Saves a lot of time if it's not even there.
Exactly. And sometimes they use, like, application-specific knowledge to make things even smarter.
Application specific, what does that mean?
Well, like, think about comments on a new post, right? You probably don't need to load the entire comment history from years ago.
Yeah, just the recent stuff.
Right. So TAO can focus on that, what's actually relevant.
Like a librarian who knows what you like to read and points you right to it.
Mm-hmm.
Pretty cool. But, it all goes back to that availability over consistency thing, right?
Absolutely. It's a deliberate choice, a core part of their philosophy. And to understand why, you got to look at their workload. What are the demands on this system? What are they optimizing for?
Yeah, good point. What did Facebook's research tell them about how people are actually using their platform?
Well, first thing that jumps out, read requests. They're dominant, like overwhelmingly so.
Really? Like most of the activity on Facebook is just reading.
Pretty much. The paper says reads are almost all of the calls to the API.
Makes sense, I guess.
Mm-hmm.
We spend most of our time scrolling, reading, watching videos. All that's pulling data from TAO, right?
Exactly. So no surprise, TAO is heavily optimized for those read operations. But here's another thing. A lot of those edge queries, those checks for connections, they come up empty.
Wait, really? Why is that?
Think about it. For every person on Facebook, there are billions they don't know.
Right, makes sense. So checking if two random people are friends, probably not.
Exactly. But from a design perspective, that's important.
Why?
Because TAO has to handle those negative queries efficiently, Can't waste time fetching data that isn't there.
Right, those optimizations for high-degree objects, that's where they come in, right?
Exactly. Streamline those queries, make them fast. Okay, so that's one thing. Another key finding, their data has a long
A
tail.
long tail.
Yeah, it means there are a few objects, super popular, get tons of traffic.
The celebrities, the viral posts, that kind of thing.
You got it. But the vast majority of objects, much less popular, it's like 80% of the activity is on 20% of the content.
Huh, interesting. So TAO has to be good at handling both, right? The super popular and the long tail.
Exactly. Balance the needs of both. It has huge implications for how they manage the cache, distribute data across servers.
It's amazing how much the design is tied to how people actually use the platform.
It is. It's custom built for this specific ecosystem, Facebook's unique needs.
Okay, so we've talked architecture, user behavior. Anything else about TAO that's like crucial to understand?
But, well, there's the whole aspect of failures, how the system handles them. That's a story in itself.
Oh, yeah, that's right. We haven't even touched on that.
We'll dive into all that and more in part 3.
All right, final part of our TAO deep dive. Ready to wrap this up?
Let's do it. It's been a wild ride. From those edge lists to caching, shard cloning, the long tail.
Phew, yeah, lots to think about. But one thing that really sticks with me is, well, the scale of it all. Billions of users constantly interacting.
It really is incredible. And the fact that it all just works seamlessly. Well, most of the time anyway.
Right, and that brings me to something we haven't really talked about yet, failures. Because no system is perfect, right?
Right. Absolutely. Things break, servers crash, networks hiccup. It's inevitable.
So what happens when things go wrong in TAO? Does the whole thing just, like, fall apart?
Nope, not at all. That's one of the most impressive things about it, how they handle failures. Remember those leader servers?
The ones that manage the rights, right, the head librarians.
Exactly. If one of those goes down, the followers, they don't panic. They can actually bypass the cache, go straight to the database for reads.
Ah, so the library stays open even if the head librarian is out sick.
Exactly. And for writes, they just redirect those to a different leader who takes over. Smooth and seamless.
Smart.
Yeah.
So they've got that covered. But what about, like, the cache maintenance system itself? Those messages that keep things in sync.
Good question. What if one of those messages gets lost or a server goes offline for a bit?
Yeah, exactly. Does everything just get out of whack?
Not really. They've built in mechanisms to recover from that stuff. Eventually, the data gets back in sync. It's really quite resilient.
It's like a self-healing system, kind of. Just figures things out, fixes itself.
That's a great way to put it. And that's what separates, good engineering from great engineering. Anticipating those problems, building in safeguards.
Right. It's not enough to just make it work. It's got to work when things go wrong, too.
Mm-hmm.
And TAO definitely does that.
Yeah.
But, as I've been learning about all this, it's clear that TAO, it's not just about Facebook.
What do you mean?
It's had this huge impact, right,
Okay.
on how we think about data storage in general.
Oh, absolutely. TAO was a pioneer in many ways. It broke new ground.
Like that whole graph abstraction thing, right? Modeling data as objects and connections.
Yeah, that's become really common now in a lot of NoSQL databases. TAO kind of showed the way, paved the path.
And the emphasis on speed and availability, even over strict consistency. That's everywhere now, right?
Right, for sure. We're so used to things happening instantly, even if it means a little sacrifice and, perfect data synchronization.
Because user experience is king,
Right.
right? If it's slow or clunky, people just bounce.
Exactly. And TAO showed everyone that this approach, it works. It can be done.
So it's not just powering Facebook. It's changed the whole game, the way we build these systems.
It's quite a legacy for sure.
It is. So I guess as we wrap this up, what are the big takeaways? What do we want people to remember about TAO?
Well, for me, it's the power of really thoughtful engineering, solving problems in a creative way, understanding the trade-offs.
Right, like there's no one-size-fits-all solution, right? Sometimes you have to prioritize certain things over others.
Exactly. And TAO shows how to do that, how to make those tough choices.
And the data analysis part, right? Understanding how people actually use the system, that's crucial.
Yeah, Facebook, they knew exactly what they were optimizing for. They built TAO for their users, their specific needs.
It's been a fascinating journey. We've learned so much about TAO, about Facebook, about data storage in general. But, like any good deep dive, it just leads to more questions, right?
Of course. That's how it always is. The more you learn, the more you realize you don't know.
Exactly. So to all our listeners out there, keep exploring, keep asking questions, keep digging deeper. And hey, who knows, maybe we'll revisit TAO down the line. Maybe there's a whole other deep dive waiting to happen. Until then, happy exploring.